In this video we're looking at 2021 paper 2 question 2, and it's all about coordinate geometry of the line. Now in part A here we're given the equation of a line and we're given a point on the line, and the x coordinate is k, the y coordinate is 2k plus 2 over 3, and we're asked to work out the value of k. Well, if we know that this point lies on the line, we can simply sub in the x and the y coordinate. So instead of an x, we sub in the x coordinate, instead of y, we sub in the y coordinate. And now we just have one equation and one unknown, so we can solve and find a value for k. Now, probably the simplest way to do this is if you just recognize, look at the second term there. It's minus 6 times this fraction. I can simply divide the 3 into the minus 6. 3 into minus 6 just goes minus 2 times. So we can just go straight from here to here. The denominator divides into the minus 6, so it's minus 2 times 2k plus 2. And then from there it's very straightforward. We end up with k is equal to minus 2. Okay, in part B here, we're given the point P, which has coordinates s and t. And then we're given two pieces of information about the point P. We're told that the point P lies on this line, and that it's 1 unit, the perpendicular distance from the point to this line is 1 unit. The first thing that should jump to your mind is that you have two unknowns, s and t. Whenever we have two unknowns, we need two equations so that we can carry out a simultaneous equation. We clearly have been given two pieces of information about the point, so we'll use each piece of information to come up with an equation. Then we'll solve that equation and we'll solve a simultaneous equation. We'll get values for s and for t. Now, there are two possible answers for s and two possible answers for t. The reason for that is that when we use our perpendicular distance formula, we're going to have absolute value signs. But you'll notice in the question, it explicitly says they just want you to find one of those values. Find one of the values of s and a corresponding value of t. Now, when I go through this, I'm going to find both of them because obviously there's two different correct answers. But let's just start off. The easiest equation to come up with is just based on the first piece of information. Just like what we did in part A, we know that this point lies on this line. So to come up with our first equation in s and t, we can just sub it in. The x coordinate is s, the y coordinate is t. And I'm simply going to sub that in here. If I sub into this, I'll get s minus 2t minus 8 equals 0. So that's the first equation in my simultaneous equation. Now obviously it's impossible to find s or t there because there's two unknowns in one equation. So I have to kind of just table that one for the moment, but that's equation 1, and we're going to come back to that once we've got our second equation. To come up with our second equation, we know that the distance from the point P to this line is 1 unit. That refers to the perpendicular distance. The perpendicular distance from ST to the line is simply 1. So I can sub into the perpendicular distance formula and I'll be able to come up with another equation in s and t, and then I'll solve my simultaneous equation. Okay, so I've started off trying to find our second equation here. I know that the distance from the point P to this line is 1. So I want to sub into my perpendicular distance formula. If you go to your maths tables, it tells you the perpendicular distance between a point and a line is this formula. And in this case, I know I can let it equal to 1 because I know the answer. A is the coefficient of x, 4, b is the coefficient of y, which is 3, c is the constant at the end, which is 6. And then the x and y coordinate are s and t. So all I did on this line was I subbed in each of those values into the equation. Now I have an equation in s and t again, but obviously I'm not ready to do my simultaneous equation when it's in this format. So the first thing I recognized was I can simplify the bottom of the fraction. The square root of 4 squared plus 3 squared is simply 5. And then I decided to get rid of my fraction, so I multiplied both sides by the denominator 5, and I ended up with this. Now, I referred to it at the start that there are two possible answers because there's two different values, two different answers you can get when you eliminate your modulus signs here. In the exam question, it only asks for one of those answers, so you only actually have to come up with one of them. But let's discuss now how we could come up with two different values. I'm going to solve this by two different methods now. Okay, so you need to remember that there are two methods for eliminating modulus signs. One way of doing it, and one that we commonly use, especially in algebra, is squaring both sides. If you square the left-hand side and square the right-hand side, you can eliminate the modulus signs. But that is absolutely not what you want to do here. If you square the left-hand side, it's double brackets. You have to multiply 4s plus 3t plus 6 by 4s plus 3t plus 6, and the question would be an absolute nightmare. So that's not the way to go in this scenario. The way to go here is to use the other option. The other option is that you take a plus in front of the left hand side or a minus in front of the left hand side. They're the two different possibilities. So if you take a plus in front of the left hand side, it just nothing happens. If you multiply something by a positive, the sign stays the same. When I simplified this down, I ended up with 4s plus 3t equals minus 1. So that's my second equation in my simultaneous equation. I'll use the one that I got earlier and this one, and I'll solve for s and for t. There is another possibility though. The other possibility is that you take minus in front of the left hand side. So you end up with minus 4s minus 3t minus 6 equals 5. Then all I did was add 6 to both sides, and this is also a valid second equation. Remember, in the question they've only asked you for one of them, so you only actually need one, and I imagine the vast majority of students would go with this one. It's a little bit harder to get here, so why would you bother using it? But now we can take the equation we got at the start of the question and this one, solve for s and t, or take the equation we got at the start and this one and solve for s and t. Okay, so the first equation we got was s minus 2t equals 8. And one of the possible second equations is 4s plus 3t equals minus 1. It's easy enough simultaneous equation. You end up with t equals minus 3 and s equals 2. The second scenario, or the second set of acceptable answers, is when you take the other equation, minus 4s minus 3t equals 11. Once again, it's an easy simultaneous equation. You end up with t equals minus 43 over 11 and s equals 2 over 11. Okay, in part C of this question, we're given two triangles and loads of information about it. The first part of the question simply asks us to find the distance AD, so the only thing that's actually relevant is the line from A to C. We know the coordinates of A are 4, 2, the coordinates of C are 16, 11. We're told that the ratio of AD to DC is 2:1. Or in other words, the distance from A to D is twice as much as the distance from D to C. The easiest way to do this question is simply use your distance formula from junior cert, get the distance from A to C. When I did that, I worked out the distance from A to C is 15. Clearly the distance from A to D is 2/3 of that. So it's just 15 by 2/3. The distance from A to D is 10 units. In the second part of this question, we're told that AB and DE are horizontal line segments. We're delving into the realm of geometry here, so we'll talk about that in a moment. We're told the distance from A to B is 33 units. We're asked to find the coordinates of B and the coordinates of E. Since AB is a horizontal line, then that simply means if we go up 33 units, the only thing that changes is the x coordinate. All we have to do is add 33 to the x coordinate. If this is the point 4, 2, 33 units to the right will give me the point 37, 2. So the coordinates of B are 37, 2. Now, I want to talk to you about geometry for a moment. You need to recognize that we're talking about similar triangles here. They've told me that AB and DE are horizontal. What's relevant there is that means that they're parallel. If they're both horizontal lines, then they're parallel lines. Let's look at the triangle CDE. First of all, it contains this angle, as does the large one. The angle C is in the small triangle and it's in the large triangle. So that's one set of equal angles that they have. Since DE and AB are parallel, then this angle and this angle are corresponding angles. This angle and this angle are corresponding angles. So all the angles in the small triangle CDE are the same or equally as big as the triangle CAB. That means that the sides of the triangles are proportional to each other. The start of the question, it told me the ratio of AD to DC was 2:1. So that tells me that the ratio of BE to EC is also 2:1. I'm going to use that fact now to work out E. Probably the simplest way to do it is, I know the coordinates of B, I know the coordinates of D, I'm going to use my ratio formula and divide the line in a ratio of 1:2. So the simplest way to think about this now is we have the line that goes from B to C. I have the coordinates of B and I have the coordinates of C, and E is the point that divides it in a ratio of 2:1. The distance from B to E is twice as big as the distance from E to C. So if you go to your maths tables, we can use the ratio formula. I've decided in this case that A is going to be 2 and B is going to be 1. Since I've labelled a 2 as my A, this is my x1, y1, and this will be my x2, y2. So I've subbed in, they're all the values I'm subbing in. It's essentially just a fancy midpoint formula. We sub it all in and we get the answer. The point that divides BC in a ratio of 2:1 is 23,8. So that's the coordinates of the point E.